Hi, I'm Robert Green, a product line manager at Keithley Instruments. Today I want to help you accurately test and safely test when you're using high voltage to make tests and measurements. We'll be using the model 2290 high voltage power supply from Keithley. That's a 10 kV output supply. We'll be sourcing that voltage to a high voltage gallium nitride diode and measuring its leakage current in its back bias mode and its breakdown voltage. And we'll be measuring the current that the diode draws with our ultra-sensitive 2635B SMU that can measure down to picoamps and less. We'll be protecting the SMU with our model 2290-PM-200 protection module. So in the event that the device breaks down, the high voltage will not get to the SMU and protect the SMU.
Whether you need a kilovolt supply to perform breakdown testing, leakage current testing, or resistance measurements on devices, the two Keithley 2290 high voltage supplies can provide up to 5 kV or 10 kV outputs. Here is the block diagram for the test setup we will use with our 10 kV supply. The supply is in series with the DUT, in this case a high voltage gallium nitride reverse bias diode. The DUT should be in a safety enclosure rated for 10,000 volts. The case can either be a case with a metal enclosure, which needs to be grounded, or the case can be plastic and isolated from earth ground. In either case, a proximity switch is needed to prevent the 2290 from outputting voltage unless the top of the enclosure is closed and properly seated upon the enclosure. Our source meter is in series with the DUT and will be used as a sensitive ammeter to measure current through the DUT. The protection module is in parallel with the source meter to provide a fast responding short circuit to prevent damage from the high voltage that could be applied to the source meter should the DUT break down. The protection module senses when the voltage across itself and the source meter exceeds 200 volts, the maximum safe voltage for the source meter. The protection module turns on and protects the source meter from high voltage damage. Here is the wiring diagram for the high voltage test setup. The wiring schematic is showing the rear panels of the high voltage supply and the source meter. High voltage cables connect from the high voltage supply to the DUT in the test fixture, and from the other side of the DUT to the protection module. On the low voltage side of the protection module, two triaxial cables essential for making low current measurements connect to separate high and low terminals on the source meter. For safety, neither the high voltage supply or the source meter will operate unless the cover of the test fixture is secured to the case. A proximity switch on the test fixture case and on the cover must be closed to allow high voltage output. Interlock cables, shown on the right of the schematic, connect to both the interlock detection input on the high voltage supply and the interlock detection input on the digital I/O connector of the source meter.
All right, now we will connect the protection module to the circuit. I'm going to connect the high connector cable from the source measure unit to the protection module and the low connection from the source measure unit to the protection module. Then on the high voltage side, I'll connect the 10 kV cable to the protection module, and I have already connected the green safety grounds from the protection module to a ground screw on the rear of the source measure unit. Now for safety, I need to run the interlock cables from the instruments, from the high voltage power supply and from the source meter into the test fixture, and this one cable combines those two interlock connections, and the proximity switch on the top of this fixture ensures that the top has to be on the fixture before we can apply any voltage. So now we want to test the leakage current of our diode. We have it back biased in our circuit. I'll apply 1,000 volts to it. And turn the output on. And you see that we have 1,000 volts across our diode, and the leakage current is only about 4 nanoamps. The power supply can measure current, but it only has sensitivity down to 1 microamp. So that is why we're using the source measure unit. I'll go to 3,000 volts. And our diode is still very good with back bias voltage leakage of only 7 nanoamps. Let's see what happens. It's a 4 kilovolt diode, so let's run it up to 4,000 volts. And it's still meeting its specification, still in the nanoamp range. Well, let's challenge it and let's go up to 4,500. It's greater than 10% above its rating. And our current is still in the nanoamp range, so we're still very much along the horizontal part of the reverse voltage diode curve. If we were interested in measuring the resistance by chance, in case this was a resistive element, we can just divide the voltage, 4,500, divided by the measured current to get the resistance. So let's be aggressive. We'll go to 5,000 volts. And now you're seeing that we're getting near breakdown as we're starting to increase the current, and you can now see that the power supply itself can measure the microamp current level. But we haven't broken down the diode yet, so let's go to 6,000 volts. Up, and that does it. We've got the trip condition. We've exceeded the 1 milliamp limit, and our protection module is protecting our source meter from protect our source meter from that breakdown of the diode, and the power supply safely went to 0 volts during that period.
I need to reset the supply because I hit the supply's current compliance limit when I exceeded the diode's breakdown voltage. So I will enter a new voltage setting and turn the output on one more time. I want to make you aware of a nice safety test fixture rated for 10 kilovolts made by Signatone. The test fixture uses a universal mounting board to accommodate a wide range of devices under test. High voltage connectors on the test fixture are compatible with the Keithley 5 kilovolt and 10 kilovolt high voltage power supplies.
Thank you for letting me show you how to accurately and safely perform high voltage testing. For more information, look at tech.com or contact your local Tektronix representative. Thank you.